Roshali and you are watching Roshal's Classes YouTube channel. We are once again with the chapter Quadratic Equation. Already the 3 videos regarding quadratic equation are uploaded on our YouTube channel. You can check the link of those videos in our description box. So far what have we discussed about this quadratic equation? In the first video, the meaning of this equation and how to check whether the given equation is quadratic equation or no was explained. Then the next thing, what are the different methods to solve this equation? Altogether, there are 3 methods, that is factorization method, formula method and completing the square method. In formula method, we come across one, we can say the special case, that is the value of b square minus 4ac. So, this value of b square minus 4ac, it decides the nature of roots of the given equation. How? All that is explained in our next video. And later, how exactly we have to use the formula to find the roots of the given equation is explained in our video number 3. That is part 3 of this quadratic equation. Now in this video, we are going to start one important method of finding the roots of the given equation, that is completing the square method. So how to find the roots of the given quadratic equation by completing the square method. So before we actually explain how to solve the given equation by this method, first let us check what exactly is the meaning of this method. So when we say completing the square method, means what exactly is expected in the given equation. Okay, let's check it. The first example, if it is x square is equal to 25. Okay, x square is equal to 25. So in this case, x is equal to square root of 25, which is equal to plus or minus 5. Means the roots are plus 5 and minus 5. Okay, one more example we'll check. If it is 4x square is equal to 11. X square is equal to 11 upon 4. So x is square root of 11 upon 4, which is equal to plus or minus root 11 upon 2, because square root of 4 is 2. So this is how we get the answer. One more example. 3x square is equal to 5. So x square is equal to 5 upon 3. So in this case, x is equal to square root of 5 upon 3. Now 5 and 3, they are not the perfect square. So what we have to say? Plus or minus square root of 5 upon 3. This is the answer. Okay. One more example we'll check. X minus 7 whole square is equal to 25. X minus 7 whole square is equal to 25. So in this case, x minus 7 is equal to square root of 25, which is equal to plus or minus 5. Now how to get the roots? Now here in this case, x minus 7 is either plus 5 or x minus 7 is minus 5. So if x minus 7 is plus 5, x is 5 plus 7, that is 12. And if x minus 7 is minus 5, x is minus 5 plus 7, and that is plus 2. So here the roots of this equation are plus 12 and plus 2. So what is the common factor in all these 4 examples? Here, in all these cases, our LHS is perfect square. Once we get our LHS as a perfect square, if we take square root on both the sides, we get the answer by some simple simplification methods. So this completing the square method means we have to make our LHS as the perfect square, and later by following some simple step we get the answer. So how exactly we should solve the given quadratic equation by this completing the square method, that will be explained with 2 examples. Now these both examples are different. So to understand this method properly, perfectly, you have to watch these 2 examples properly. Okay. So let's solve two examples on this completing the square method. Now, when we use this completing the square method to solve the given quadratic equation, we have to follow few steps. Means there are two important points which you have to remember while solving this. So while solving the examples, I'll be explaining those important points. So again I repeat that watch these two examples properly. So the first example, x square minus 2x is equal to 1. Okay, x square minus 2x is equal to 1. Let us bring 1 on LHS. X square minus 2x minus 1 is equal to 0. Now the very first thing what you have to check here is that our value of a, if it is other than 1, okay, if it is other than 1, we have to divide the entire equation by that value of a. Means in short, we want coefficient of x square to be 1. It should not be any other coefficient. Coefficient of x square, it has to be 1 to follow this completing the square method. So this is the very first condition to follow this method. Here already it is 1. Okay. Our coefficient of x square means value of a is 1. So the first point is sorted. Next point. Now here how to make this LHS a perfect square. So here one step what we have to follow is just find what is half into coefficient of x and square of that. We have to find this value. Half into coefficient of x and square of it. So in this case, half into coefficient of x is minus 2. Minus 2 and square of it. 2 ones are, but it's minus sign. So now what we have in the bracket? 1 into minus 1, we get minus 1. 1 into minus 1, we get minus 1 square, which is plus 1. Now once we get this value, okay, once we get this value, where to place this value? Here, x square minus 2x. After this, we have to place this value. Plus 1 and then write the remaining part. Okay, now see one thing. In equation, whenever they give one equation, we don't have any rights to disturb the balance of that equation. So, whenever we solve the equation, if we add anything, we have to subtract the same thing. Or we can say add same thing on both sides or subtract same thing on both the sides. If we multiply, we have to multiply each and every term with that same number. If we divide, we have to divide each and every term by that same number. So this rule we have to follow. So here what you can say, add 1 on both sides, or here after adding 1, immediately we can write minus 1. Add and subtract, okay? Add and subtract whatever answer we get here. And next we have to write this remaining term is equal to 0. Now here whatever part we get here, first 3 terms is perfect square. Yes, this term and the last term is perfect square. So what you have to do is just write the root of this first term, then write the root of this last term, and whatever sign is there of this middle term, just place it here. Square minus 1, it's minus 2 is equal to 0. Fine. Now x minus 1 whole square is equal to minus 2, we will shift it to RHS. So x minus 1 whole square is equal to 2. Is equal to 2. So x minus 1 is equal to square root of 2. And as 2 is not a perfect square, here itself we will write plus or minus square root of 2. So here x is equal to plus or minus square root of 2 plus 1. This same answer we can write as x is equal to 1 plus or minus root 2. So one root is 1 plus root 2 and the other root is 1 minus root 2. So in this case we get the answer of our quadratic equation by completing the square method. So which points you have to remember? First thing is, if the value of a, if it is other than 1, divide all the terms by that value. Okay, means what? We have to make coefficient of x square 1. Then the next step is half into coefficient of x, whole square of that. We have to get the value, answer for that. Then whatever answer we get here, we have to add and subtract immediately after these two terms. Okay, after these two terms we have to add this and subtract it and then write the remaining terms, and just the simple simplification gives us our answer. So completing the square method is also not so difficult. If you understand just this one or two things here, even this method is quite easy to find the roots of the quadratic equation. Okay, now one sum is done. As I said, I am going to solve two examples. Now let's move to our second example. Let's see how to find the roots of this equation by this method. Now the next example, 2x square plus x is equal to 5. 2x square plus x is equal to 5. Now here the very first thing, 2x square plus x minus 5 is equal to 0. We wrote this equation in general form. Now here our value of a is not 1, it's 2, and we don't want any other coefficient other than 1 for this x square. So to remove this 2, we have to divide all the terms by 2. Let's divide this. 2x square upon 2 plus x upon 2 minus 5 upon 2 is equal to 0 upon 2. So what we get here? Here 2 and 2 gets cancelled. X square plus x upon 2 minus 5 upon 2 is equal to 0. Okay, first part is done. We made value of a 1 here. Now the next thing, we have to find our one term, which is going to be our last term of the perfect square. Now what is the next step to be followed? What we have to do here? Yes, we have to find the value of half into coefficient of x, the whole square. Let's see what we get here. Half into, now here coefficient of x is 1 upon 2. 1 upon 2 the whole square. Now here 1 upon 2 into 1 upon 2 is 1 upon 4 the whole square, which is 1 upon 16. 1 upon 16. Now this value we have to add and subtract. Add and subtract. Here x square plus x upon 2. Immediately after these two terms we have to add this plus 1 upon 16 and subtract this. Minus 1 upon 16 and write this term. Minus 5 upon 2 is equal to 0. Now as I said, this part is perfect square. Okay, now don't think much. If you are perfect in this, no, be sure that whatever you get here is going to be the correct answer. So here x 1 upon 16 is square of 1 upon 4. So this part is square of x plus 1 upon 4 is equal to, we will shift these terms on RHS, is equal to 1 upon 16 plus 5 upon 2. Fine. X plus 1 upon 4 whole square is 1 upon 16 plus 5 upon 2. We will solve this. X plus 1 upon 4 whole square is equal to, now in this case 16 and 2 LCM is 16. Simple fraction addition rules we have to use here and solve. 1 plus 2 8s are 16. So 8 into 5 is 40. So here we get 41 upon 16. Fine. So x plus 1 upon 4 is equal to square root of 41 upon 16. Square root of 41 upon 16, which is equal to plus or minus root 41 upon 4. 41 is not perfect square, so it will remain under root sign. Square root of 16 is 4, so we can find square root of 16 and write it as 4. Now x is equal to plus or minus root 41 upon 4 minus 1 upon 4. So as denominators are same, this same thing we can write as plus or minus root 41 minus 1 upon 4. So these are the roots of the quadratic equation. Means one root is plus root 41 minus 1 upon 4 and the other root is minus root 41 minus 1 upon 4. So this is how we use this completing the square method to find the roots of the quadratic equation. So I think 2 examples are enough to explain this method. Hope this is quite clear. Apart from this, if you want us to solve any examples of this quadratic equation, you can drop your request in our comment box. We will definitely think over it. And my dear students, to get the updates of such useful videos, please don't forget to subscribe our channel, that is Vishraj Classes. Do share these videos among your friends. And my dear students, thank you so much for watching this video.